Today we will review section 10.5 to 10.7. Example 1 is a review of section 10.5, solve quadratic equations by completing the square. Solve 3x squared plus 12x equals 18 by completing the square. So this is a review of section 10.5, completing the square. So the way, before you can complete the square, you have to get the constant isolated on one side of the equation, which it is. 18 is the constant because it's the number that's not being multiplied by a variable. However, there's one thing we need to do before completing the square. You have to make sure that the variable squared term is not being multiplied by a number. So we need to get rid of the 3 by dividing each side by 3. So each term gets divided by 3. 3x squared divided by 3, the 3's cancel out to get x squared. 12x divided by 3 is 4x. 18 divided by 3 is 6. Now we can complete the square because the variable squared term is not multiplied by a number and the constant is isolated on one side of the equal sign. So what we need to do now is make, well, we can just make one set of parentheses. No, actually, let's do this. Take half of the coefficient of the variable term, so half of 4, which is 2, and add 2 squared to each side. So we have x squared plus 4x plus 2 squared equals 6 plus 2 squared. And then make a set of parentheses, put the variable at the beginning of the parentheses, put the half of the coefficient of the variable term at the end of the parentheses, half of 4 is 2, and then square it. And 2 squared is 4, so we have 6 plus 4. The reason I did x plus 2 squared is because that's how you factor anytime you have a variable squared without a number being multiplied, a variable term and a constant, a number not multiplied by a variable, and the constant is the square of half of the coefficient of the variable term. Because notice if I do x plus 2 squared, which is 2x plus 2's multiplied together, I can use FOIL since I have 2 terms in parentheses times 2 terms in parentheses, first, outer, inner, last. Multiplying the first term in each of the parentheses, x times x is x squared. Multiplying the outer terms, x times 2 is 2x. Multiplying the inner terms, 2 times x is 2x. And multiplying the last term in each of the parentheses, 2 times 2 is 4. Combining the like terms, 2x plus 2x is 4x. Notice I end up with the same expression that is on the left side of the equation in the previous step. Okay, now that the, so that demonstrates why it was factored correctly into x plus 2 in parentheses squared. Now that I have the square isolated, it's just the parentheses squared on the left side, we can get rid of the square by taking the square root of each side. Square rooting cancels out the square. Now we have x plus 2 on the left side. Anytime you take the square root of both sides, make sure you have plus or minus on the opposite side of the equation from the variable, because keep in mind a square root technically has two answers, a positive and a negative answer, because a negative number multiplied by itself can also be a positive number. Like negative square root of 10 times negative square root of 10 is also 10, not just positive square root of 10 multiplied by itself. Then subtract 2 from each side, and that's going to give us x equals negative 2 plus or minus square root of 10. There's going to be two answers, negative 2 plus square root of 10 and negative 2 minus square root of 10. Let's put that in the calculator. So make sure you use the negative button, not the minus sign. So negative 2, and then plus, use the second button, and then hit the x squared button to get that square root sign above the x squared button. And then 10, enter. That's 1.16 when you round it to the nearest hundredth or the second decimal place. And then negative 2 minus square root of 10, rounded to the nearest hundredth or second decimal place, is negative 5.16. So 1.16 comma negative 5.16. Those are our two approximate solutions for x. You can check the answer by substituting in negative 2 plus square root of 10 in for the x's in the original equation, and if you get a true equation, you know you have the right answer. You could do the same thing for negative 2 minus square root of 10, or you could use 1.16 and negative 5.16 to substitute in for the x's, and if you get approximately true equations in each case, you know you probably have the right answer. Now let's go to example 10.6. All right, example 10.6, a review of section 10.6. Solve quadratic equations by the quadratic formula. Solve 4x squared plus 3x equals 1. So in order to use the quadratic formula, you need to get everything over to one side and make it all equal to 0. And you can use the quadratic formula for quadratic equations, equations in which the highest power of the variable is 2. All right, so once you have a quadratic equation equaling 0, a is the coefficient of the variable squared term, 4. B is the coefficient of the variable term b. And c is the constant, the number not multiplied by the variable. And we can plug that into the quadratic formula, which you need to memorize. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And if you watch the beginning of my video for section 10.6, I show you how the quadratic formula is derived, how they came up with it, and why the quadratic equation needs to be set equal to 0 before you can use it, before you can use the quadratic formula. So substituting the numbers in for a, b, and c, that's negative 3 plus or minus the square root of 3 squared minus 4 times 4 times negative 1 over 2 times 4, which gives us negative 3 plus or minus, make sure to follow PEMDAS within the square root there. E before exponents, before M for multiplication, before S for subtraction. 3 squared is 9. An even number of negative numbers multiplied together is positive. 2 negatives multiplied together is positive. So negative 4 times negative 1 is positive 16. 2 times 4 is 8. So we get the square root of 25, which is 5. And I'm going to move up here since I ran out of room. So there are two answers because of the plus or minus. Negative 3 plus 5 over 8 and negative 3 minus 5 over 8. So x equals negative 3 plus 5 is 2, so 2 over 8. Negative 3 minus 5 is negative 8. Simplifying that, 2/8 simplifies to 1/4 if you divide both the top and bottom by 2. And then 8 divided by 8 is 1, so we get negative 1. So you can check your answer by substituting in 1/4 for the x's in the original equation. Make sure to follow PEMDAS, and if you get a true equation, which you would, you know that you have the correct answer, and do the same thing for negative 1 to check your answer. We could have also solved this quadratic equation by factoring. I know that not all quadratic expressions are factorable, but I know this one is because the result of the square root in the quadratic formula was a whole number, which means that 4x squared plus 3x minus 1 was factorable. Just to review factoring really quick, solving by factoring, you can make two sets of parentheses, and we need two terms that multiply together equals the variable squared term, 4x squared. Well, that would be 2x and 2x. Or you can use 4x and x. And then we need two numbers that multiply together equals the constant negative 1. So that would be positive 1 and negative 1. And then let's use FOIL to make sure it was factored correctly. First outer, inner, last. Multiplying the first terms together, 2x times 2x. Okay, well, yeah, let's see if that works. So 4x squared outer, 2x times negative 1 is negative 2x. Inner, 1 times 2x is 2x. 1 times negative 1 is negative 1. Combining the like terms, negative 2x plus 2x is 0, so it cancels out. We end up with 4x squared minus 1, which is not the same thing as 4x squared plus 3x minus 1, so that does not work. Normally I would say try switching positive 1 and negative 1, but it's just going to be the same thing. Let's try 4x and x. I think it's important to review the factoring here. So 4x and x. 4x times x equals the variable squared term 4x squared. Let's use FOIL to make sure that it was factored correctly. So first term in each of the parentheses, 4x times x is 4x squared. Outer, 4x times negative 1 is negative 4x. Inner, 1 times x is positive 1x. Then multiplying the last term in each of the parentheses, 1 times negative 1 is negative 1. Negative 4x plus 1x is negative 3x. So we end up with 4x squared minus 3x minus 1, which is not quite the same thing as 4x squared plus 3x minus 1. So let's try switching the 1 and the negative 1. So let's put negative 1 here, positive 1 here. Now let's use FOIL, first, outer, inner, last. That's going to give us 4x squared plus 4x minus 1x minus 1. Combine the like terms. 4x minus 1x is positive 3x. Now we end up with the same expression that we had on the left side in the previous step, so it was factored correctly. We have two quantities that multiply together equals 0, so one of those quantities must be 0. If 4x minus 1 equals 0, which is possible because 0 times x plus 1 is 0, because anything times 0 is 0, then add 1 to each side to isolate x. That's 4x equals 1. Divide each side by 4. X equals 1/4, which is exactly what we have here. The other possibility is that x plus 1 could equal 0, in which case x is negative 1, because negative 1 plus 1 is 0, or subtract 1 from each side, which is the same answer that we got over here. But often quadratic expressions cannot be factored, so often the only way to solve for x is to use the completing the square method or the quadratic formula method. If there was no variable term, if there was no 3x here, then we could use the square root method, where you isolate the variable squared and then take the square root of each side, making sure to have plus or minus on the opposite side of the equation from the variable, which we learned about a couple lessons ago. All right, let's go to the last example problem, section 10.7, the most recent lesson we've covered. Section 10.7 was interpret the discriminant. And we're given part A, B, and C. Part A, we have the equation negative 16x squared plus 8x minus 1 equals 0. So the discriminant is the expression underneath the square root in the quadratic formula, which is b squared minus 4ac. Right, remember the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. The discriminant is just the part underneath the square root in the quadratic formula, b squared minus 4ac. It's called the discriminant because it discriminates how many solutions you can expect to get for x. Because if b squared minus 4ac is positive, then you're taking the square root of a positive number, which has two solutions technically, because a positive number multiplied by itself can equal a positive number, and a negative number multiplied by itself can equal a positive number. If the discriminant b squared minus 4ac is a negative number, then there's no solutions, because no number multiplied by itself equals a negative number. If b squared minus 4ac is 0, then there's one solution, because the square root of 0 is just 0. Right, 0 multiplied by itself is 0. So, and plus or minus 0, negative b plus or minus 0 over 2a is just going to give you the same number whether you do plus 0 or minus 0. So let's put number of solutions here in the last part of the table. Okay, let's figure out how many solutions we can expect to get for x for part A. All right, so that's going to be, well, we have a quadratic equation because the highest power of the variable is 2, and it's an equation, of course, because there's an equal sign, and it all equals 0. So we can use the quadratic formula or the discriminant. A is the coefficient of the variable squared term, b is the coefficient of the variable term, and c is the constant whenever you have a quadratic equation equaling 0. So now substituting into the discriminant, that is 8 squared minus 4 times negative 16 times negative 1. And then following PEMDAS, doing E for exponents before M for multiplication or S for subtraction. 8 squared is 64. Negative 4 times negative 16 times negative 1 is negative 64. So we get 0. So there is one solution. Because the square root of 0 is just 0. Just one result. And negative b plus or minus 0 over 2a is going to give you the same result whether you do plus 0 or minus 0. And then you can, if you substitute in for a, b, and c in the entire quadratic formula, you can find what that one solution for x is, that when substituted in for x would make the equation true. Now let's go to part B. Equation B, 4x squared minus 5x plus 2 equals 0. 4x squared minus 5x plus 2 equals 0. And substitute into the discriminant b squared minus 4ac. That's going to be negative 5 squared minus 4 times 4. Wait, minus 4 times 2. Negative 5 squared, negative 5 times negative 5 is positive 25. Negative 4 times 2 is 32. 25 minus 32 is negative 7. So there's no solution because square root of negative 7, there's no number that multiplied by itself equals negative 7 or any negative number. So no solution. There's no number that we can substitute in for x that would make this equation true. And if you graph the equation y equals 4x squared minus 5x plus 2, there would be no x-intercepts. There'd be nowhere that the parabola would cross the x-axis, because at the x-axis, y is 0. And as I just mentioned, there's no number that you can substitute in for x that would make this a true equation equaling 0. Now let's look at part C, last one. We've got x squared plus 3x equals 0. Yeah, so this was A, of course, this was B, and this was C. All right, so x squared plus 3x equals 0 is the same thing as x squared plus 3x plus 0 equals 0. Or, well, x squared is the same thing as 1x squared because multiplying by 1 does not affect the value. So we have a quadratic equation equaling 0. Therefore, the coefficient of the variable square term is A. The coefficient of the variable term is b, and the constant, the number not multiplied by the variable, is c. Substituting into the discriminant b squared minus 4ac, that is 3 squared minus 4 times 1 times 0, which is going to give us, following PEMDAS, doing E for exponents first, 3 squared is 9, then M for multiplication, 4 times 1 times 0 is 0, 9 minus 0 is 9. So it's going to be one solution. Oh, sorry, two solutions. Sorry, two solutions. Because the square root of 9 technically has two answers, positive 3 and negative 3. Because positive 3 multiplied by itself equals positive 9, and negative 3 multiplied by itself equals positive 9, because a negative times a negative is positive. And you can figure out what those two solutions are for x by substituting in for b, a, and c in the entire quadratic formula. Or, this is actually easily factorable. You can factor out the greatest common factor x from these two terms. So it's x times x plus 3. It's factored because you have something times something else. And if you multiply that out, x times x is x squared, x times 3 is 3x. You end up with the previous expression, so it's been factored correctly. You have two quantities that multiply together equals 0, so one of those quantities must be 0. Either x is 0 or x plus 3 is 0. If x equals 0, well, then x equals 0. And if x plus 3 equals 0, then x is negative 3, because negative 3 plus 3 is 0. So those are the two solutions, just FYI, but you can find those two solutions by just using the entire quadratic formula as well in this equation here. And that concludes our review. Have a let me show my face, just one second. Have a blessed, happy Holy Week, and a very happy Easter. God bless you all.